Hey guys, Mr. Backerberg here. In this video, we're going to look at matrix multiplication. When we're doing multiplication with matrices, there's actually two different kinds of multiplication, and the first one we're going to look at is called scalar multiplication. And when we're dealing with matrices, a scalar is just some real number. So let's say we had some matrix A, and I'm just going to give it some general entries. A, B, C, D, E, F. But let's say we wanted to take some scalar k times that matrix A. Then the way scalar multiplication works is we're going to take that scalar, we're going to take that real number, and it's kind of like the distributive property. We have to multiply that k value by every individual entry within our matrix. So we would have to take that k value times A, we would have to take that k value times B, the k value times C, and do that exact same thing to every single entry in our matrix. So let's say we had the matrix A and its entries are 3, 7, 0, -4, 1, and 9. But let's say I wanted to do 3 times matrix A. Then what I have to do is inside of this matrix, I need to take 3 times every single entry. So if I take 3 times that first entry, which is 3, we're going to get 9. 3 times 7 is 21. 3 times 0 is still 0. 3 times -4 is -12. 3 times 1 is 3. And 3 times 9 is 27. So it's kind of like the distributive property where we have to distribute that scalar to every single entry within our matrix. Now, the other type of multiplication that we can do with matrices is multiplying two different matrices together. So let's say we had a matrix A and a matrix B, and we wanted to multiply them together. The first thing we need to check when we're doing matrix multiplication is the order of our matrices, because we need something special to happen with the order in order to multiply these two matrices together. So let's say matrix A had an order of m by n, and let's say matrix B had an order of n by p. So what I want you to notice is that these middle numbers, the number of columns from matrix A and the number of rows from matrix B, that needs to be the exact same number in order for us to be able to multiply these together. If this number is not the same, then we cannot multiply these together. So for example, if matrix A was a 2 by 3 matrix and matrix B was a 3 by 2 matrix, that would work because this middle number is exactly the same. But if matrix A was a 3 by 2 matrix and matrix B was a 3 by 2 matrix, then these middle numbers are not the same, so we couldn't take A times B. Now when we're doing matrix multiplication, we use something called row by column multiplication. And what that means is we're going to take the values from the rows of our first matrix and multiply them by the values from the columns of our second matrix. And I think it's easiest to talk about this by doing an actual example. And I'm going to try to color code this the best I can. So let's say we had matrix A with the entries 2, 1, -3, and 0, 1, 2. And let's say we had matrix B as 1, -4, 0, 2, 1, 0. The first thing we want to look at are the orders. So this first one is a 2 by 3 matrix, and my second matrix is a 3 by 2 matrix. So we notice that these two numbers in the middle are the same, which means that we can do the multiplication. So we're going to do that row by column multiplication, and here's what that means. If I wanted to take A times matrix B, then what I want to do is take the first row from matrix A and multiply those values in there by the first column from matrix B. So I'm going to take the first entry, 2, times the first entry, 1. But then I'm going to add on the second entries multiplied together, so 1 times 0. And then I'm going to add on the third entries multiplied together, so -3 times 1. So 2 times 1 is 2, plus 0, plus -3. So we get -1 as our answer. And we're building a new matrix. And because we multiplied the first row by the first column, then this entry goes in the first row, first column. And then I'm going to switch colors here to try to keep things straight. Now what we need to do next is take our first row times the second column in matrix B. So we're going to take 2 times the -4 plus 1 times 2 plus negative 3 times 0. 2 times negative 4 is negative 8, plus 2 plus 0. So we're going to end up getting negative 6 there. So this was from the first row times the second column. So this answer goes in the first row, second column. Now we've taken row 1 times both of those columns. So now we move on to row 2. So I take this row and I'm going to multiply it by the first column. So I take the 0 times 1 plus 1 times 0 plus 2 times 1. And when we add all those together, we should get 2 as our answer. Now this was the second row times the first column, so I put this answer in the second row first column. And then I need to take this second row times the second column. So I take 0 times negative 4 plus 1 times 2 plus 2 times 0. And in there we end up getting 2 as our answer. Now this was the second row times the second column, so I fill in that value in the second row, second column. Now this new matrix over here is going to be our answer, and this matrix has an order of 2 by 2. So when we looked at the orders initially, we checked the middle numbers to make sure that they were the same. And that's what tells us if the multiplication can actually happen. But then as we look at the outer numbers, that actually tells us the order of our new matrix. So because we've got a couple of 2's on the outside, our answer is a 2 by 2 matrix. So let's look at another example in here. I've got two matrices, A and B. Matrix A has the entries 1, negative 2, 7, 3. And matrix B has the entries 1, 0, negative 4, 3, 1, 8. The first thing we want to do is look at their orders. A is a 2 by 2 matrix, and B is a 2 by 3 matrix. So if I want to do A times B, I look at the middle numbers there. We've got a couple of 2's, which means that we will be able to do this multiplication. If we look at the outer numbers, then our answer that we're going to get should be a 2 by 3 matrix. Now we're going to do our row by column multiplication. So I'm going to take the first row from matrix A times the first column from matrix B. So we take 1 times 1 plus negative 2 times 3. When we add those together, we should get negative 5. Now that was the first row times the first column, so that answer goes in the first row, first column. Then I take the first row and multiply by the second column from matrix B. So I take 1 times 0 plus negative 2 times 1, and I should get negative 2 as that answer. Now that was the first row times the second column, so this answer goes in the first row, second column. Then I need to do my first row times my third column. So I take the 1 times the negative 4 plus the negative 2 times the 8. And when I add those together, we should get negative 20. Now that was the first row times the third column. So I put this answer in the first row, third column. Now I've used the first row with all 3 columns. So now I need to move on to the second row and start over with that first column. So I take the 7 times the 1 plus the 3 times the 3, and that should give us 16 as our answer. Now that's the second row times the first column, so this answer goes in the second row, first column. Then I take my second row times my second column, so 7 times 0 plus 3 times 1. When we add those together, that should give us 3 as our answer. That's second row, second column, so my answer goes in the second row, second column. And then lastly, I need to do my second row times my third column. So 7 times negative 4 plus 3 times 8. That should give me negative 4 as my answer. That was the second row times the third column. So this answer goes in the second row, third column. So this is our answer when we do A times B. Now let's say we wanted to think about this a little bit differently. Let's say we wanted to do B times A instead. The first thing we would have to look at is their orders. So B has a 2 by 3 order and A has a 2 by 2 order. Now notice when we flip-flopped the order of these things, now those middle numbers are not matching up, so we would not be able to do this multiplication. That's going to be it for this video. Thanks for watching.